Yeah, so this is a paper we had essentially to show the findings we had from a short scoping study, and together with or for the Wellcome collection. And Christy is also here in case you have specific questions about the collection of the Medical Officer of Health reports. And so, yeah, as you can see from the title, we don't promise necessarily the final answers to all the questions of these problems, but there are some interesting findings there. So what are these reports? So this is actually a quite large collection of medical officer for health. So these were officers who were instated in the UK from the 1800s onward, and so we have the collections about 130 years. And so I think there's new numbers, there's now about 75,000 reports, I think you said, and they all have been scanned and OCR'd as well. And yeah, you can see the website there, the link is on top, and you can use it to filter by time period and by location as well, so it's quite a nice resource. And so in the reports, there's a lot of textual reporting, so narrative textual content. But what we are mostly interested in is the tabular content. So it's many hundreds of thousands of tables. And in those tables, they deal with topics like, you can see here, birth and death statistics, diseases, population statistics, causes of death, and actually it's quite, you can get quite lost easily in the data if you start reading, and there's the most incredible causes of death back then, but it's a quite interesting resource. And so yeah, some other things like school-related things and food inspections, they really like their inspections. And yeah, you can see an example of one table. It's not always neat and tidy like that. Sometimes it's mixed with other text and maybe continued across pages and things like that. So yeah, this is the interface, the web interface. So you see usually a page on top. You can browse the reports, and then on bottom you see it replicated in web form the content. And as you can see, also the tables have been replicated in HTML. And so what they did is very costly, actually. Get the OCR results, and they were corrected, and then extracted the tables into dedicated XML formats. So you can download all of that data and do whatever you want with it. But it's just a reproduction of the original table. So it's not. You don't get necessarily the statistical information easily. So you still would have to copy it into a spreadsheet and link the data yourself somehow at the moment. And yeah, so maybe very quickly, there's a bit more about that in the paper, so about current practices regarding tabular data. Of course you can guess, so standard OCR is not good enough for this task. So obviously you need the accuracy for the characters, so for actual values you want to have, but also the context, so the rows and the columns, the exact location, and what the meaning of this table cell is, and so on. And so what is commonly done at the moment, because it's quite a challenging task, usually the smaller projects, they will only give you like an index of the images, so either by item, so for a whole book maybe you get an index and you have to browse through the images yourself, or maybe in the better cases you get it per page, so whatever is on the page is indexed and you can find that image. And in some cases, like in the MOH reports, you also get manual corrections and as I mentioned, the provision of dedicated table formats to download. And so what's done very rarely at the moment, because it's either super difficult or it's very expensive and labor intensive, is that you get the full statistical information extracted from the original images. And so that means data you can use, you have a database and it's integrated and you know what it means and it's complete. So that is only done in very few projects in the moment. So one of these, maybe I should mention that, is we've actually just finished that, is together with the Office for National Statistics, about the 1961 census for England and Wales. So that's where we really extracted like millions of values together with their meaning in a structured database, and we delivered that to the ONS, and it's at the moment being checked for publication. So the actual scoping study we did was more or less to understand what is the tabular data in those Medical Office for Health reports, and also look at ways how we might be able to extract the data with current technologies, and maybe something we would have to develop. And also have a look or ask users actually what they would need, and what they think of the current interface of the reports, and what would be their expectations for future development as well. And that all the data was basically, because that's the data that is available at the moment in detail, is the Greater London subset of this whole data set. So the first thing we did, just to see what kind of tables there are, because there's no real overview exactly, and how often these tables appear, is to have a textual analysis. So we actually used a tool we had developed in-house, it should also be published soon, for social media analysis, so a slight different use. And just to group all the tables, so the table captions we had, and we also had the row and column headers, and then group these by topic, and then get a list of more or less how popular these topics were in the reports. So as you can see in the table, so the most popular are the causes of death and demographics, diseases, and as I said, very popular inspections. And so this was usually standardized across the country, so it should have a fairly common format, these reports. So also, we have a range of geographies. So mostly it's arranged in districts. So in the UK, it varies over the years, but usually you have a few hundred or more than 1,000 districts about. But sometimes you also have tables for higher geographies, so for the whole country, or for slightly smaller ones as well, as like wards or sub-districts and thus. And as I mentioned, there's a big variety of information content, but also of physical structure of the table. So there was no standard format how a table should exactly look. So every typesetter, every report might look slightly different. Maybe they have some extra columns here and there from some wards, or where they wanted some extra information. Then you have all of that across many locations and across many, as I said, 130 years. So you have to expect a lot of variation in there, but you can model all of that in a flexible data model. And so we had a little bit of a look at some taxonomy, say for causes of death and how they changed over the years. So it's doable. And on the right you see just the same topics we had before, just a little bit more in a hierarchy. Okay. So as for the extraction of the tabular data, so because we have the Greater London data, but what about the rest of the country? So how could we maybe get that data in a slightly less costly way? Because it's just having someone sit there and typing it all and creating the tables is very costly, even if you outsource it to someone else. And so what we had for experimentation is we had all the OCR results in Alto format, and for Greater London also corrected, and the table XMLs. And we also had we also ran FineReader just to have something to compare, say, what would an off-the-shelf OCR tool do with this kind of data. And this is what the FineReader outputs here, these examples. So it's not very consistent. So the problem is, start with the good thing. So it gets most of the column headers and row headers correct. and also some of the values in the table. Well, it misses some of the empty cells which just have like a dash or hyphen, but that's not really important because if it's just a dash, it means 0, so that's okay. But I don't know if you know, FineReader does have a table recognition feature, but you can see only in the left example it's actually found the table there, and it's not always complete, and also the internal structure is not represented well. And on the right side, you see that it didn't really recognize the table, but at least it has all the separators, so you could guess from that there is a table there. Yeah, so that's just that. So, and then we created a little prototype to see with these variations in the tables, can we still get the core data of some of these tables that we want to look at, say in this case, the causes of death. And so we knew the kind of the classification system they used, and usually they also appear always in the same order. So in the table from top to bottom, you have different causes of diseases and death, and they appear in that order. So that is a data model you can use, and based on that information, you can do some flexible text matching, string matching, and find the column headers. Even if there are some gaps in between, you can just ignore. Also extra columns you can ignore, because, as I said, there's maybe some extra data they had for one district, but you can ignore it for the overall picture. And that worked quite well, even on the FineReader results, which are not 100% accurate, of course, but once you have all the locations of the cells, you could maybe then run a secondary OCR and see if you can improve the results. Yeah, so we think it's doable for some core data across all of the years. And so one more thing you can do, of course, is since most of the table they have like, as you see at the bottom there, they have totals, so summations of the whole row, of the whole column, and also some of the rows have totals. So you can use this as to check for internal consistency. So if all the numbers you extracted add up, and if not, you have to check or maybe do some post-correction, crowdsourcing, or some other processing. And the same thing you can do across geographies, of course. If you have multiple levels of geography, then you can also sum up and see if everything works out. And it's a good way. It's a good way to validate your data. And yeah, of course, there's one limitation because there's such a big variation in the type of tables. There are some tables which appear, in worst case, only once in all the reports, and these are very rare. And obviously, it wouldn't make sense to train a model to extract those. So you have to limit it somehow to the most common tables, and the rest maybe you can do manually if you really need them. Otherwise, just leave them for people to look at on the image. And yeah, I mean, as I said, the idea is maybe to have it all at some point ingested into a database for online access and analyses. So just very briefly about the user consultation we did. So we had an online survey where we invited researchers and experts of the field to take part in various questions. And we also had an informal meeting with researchers at the University of Manchester. And the findings, we will find more in the paper on that. But so first of all, there was some people knew about the MOH reports and the website, and but not everyone knew, and also not everyone knew the functionalities that exist and things like that. But the ones who knew about them, they thought it's a really good resource. And for instance, the search by topic and time period, and so it's quite good. And the most of them would also be interested in statistical or tabular data. So this is the bottom graph here, the chart, and so yeah, most people would be really interested in this extension, essentially, of the data. Also, yeah, I mean, this is just an overview of what people would be interested in terms of topics. So the most interested would be, again, demographics, mortality, and yeah, also ailments in general, and fertility. And also a big interest is for instance, some researchers were interested in how diseases spread over time and over geography, right? And so this kind of data would allow this sort of research. So just a quick conclusion here. So yes, there is interest in this data, and we think an automated extraction is possible. So maybe that's something for future work to work on, with the limitations I mentioned. So we would go for a flexible matching approach. As I mentioned, you look for the data you are interested in, you can ignore the rest. And together with the data validation, you should be able to at least get a confidence on what is correct and maybe work on the rest in some other way. So yeah, and this kind of data would allow, of course, other research, new research, which is not possible on the purely qualitative research, but it could also provide a context for the qualitative research. So yeah, how many people live there, what were the diseases, and the variations in the different cities versus the rural areas and things like that. So yeah, future work is kind of, we could do small steps first, like creating just a nicer index for tabular data, so to be better able to access. So that's the step I mentioned before, the smallest step. And then we have, of course, the next steps because we already have the corrected data for Greater London, maybe create a database containing all the tabular data for Greater London. And then finally, if there's funding for this, we could just do the bigger project where we just try to extract the interesting large-scale data from all the reports. And maybe, yeah, obviously we don't have to use FineReader necessarily. We can use some more targeted approach as well. Okay, yeah, thank you. That's it.
Thanks very much, Christian, and I'm sure you've probably seen this mini poster in the poster session, but I can think that's a bit of PR for it there. So, does anybody have any questions for Christian? Not at this stage, but I think this is incredibly useful in this data set, this table extraction. I mean, I think it could be used in so many different things, so I think it's incredibly useful. So I think we're running about out of time, so if there's no questions for Christian, let's thank you very much again.